of you will look. Okay, so let's look at 17. Good. In a previous year, 59% of females. So that's our P0. 0.59. I take notes as I read, and you should always do that. Females aged 15 and older lived alone. Okay. The sociologists test whether the percentage is different today by conducting a random sample, very important, of 700, so that's our N, age 15 and older, and finds that 410, that's our X, 410 are living alone. Is there sufficient evidence at alpha 0.05 level of significance to conclude that the proportion has changed? The keyword is change. It does not give us direction. Okay? So I immediately write the null hypothesis as P being the same. This is the P0 coming from, so P0 and H0. That's why this is the number that we need to use. And the alternative has changed. It does not give direction. It doesn't say increase or decrease. It only says it's not the same. At alpha this. So the P hat right away, we know it's X over N, which is 410 over 700. Also, the randomization. Yes. N is less than 0.05 of the entire population, of course. N is only 700 people out of 300 million. Now, I have to test N P0, 1 minus P0 to be greater than or equal to 10.
I already did it. It is greater than 10.
But I need the number because you will probably ask us to put the
number. It's 169.33.
Excellent. Thank you. Okay, so let's go back. Okay, so we enter 100, let's say, around to 1 decimal place, 169.3. You understand that this is very important because otherwise we cannot conduct the test. If these three conditions are not fulfilled, the test cannot be conducted. It will mean nothing. The sample size is less than 5% of the population size, and the sample is random. Can be reasonably assumed to be random is given. It is given to be random. It says a random sample of. So this time it's given to be random. The requirements for the test for testing the hypothesis are satisfied. So careful. If it says in the problem random, then you have to use is given to be random. If it says polls blah blah blah, you may say, I think it's reasonable to assume such and such. Okay, we already have the information. It's still about proportion. It's still the equal symbol. And we still have the 0.59. Of course, this is still about proportion. This is still 0.59. And this has to be not equal to, because it says the keyword has changed. It doesn't say increased. It doesn't say decreased. So this will be a two-tailed test. Okay, now in order to determine the test statistic, we go to stats, tests. Again, it's for one population, not two populations, one proportion, so that's 5. Tony, thank you. I think Robin is on the case. Thank you so much. Okay. Oh, it's fixed. Thank you so much. I'll ask one of my students to check. Thank you. I appreciate your call. Bye. I don't want you to miss the instruction, but at some point in time, if anyone would like to check, I would highly appreciate it because they said that it was fixed. Okay, so 0.59, and then we have 700. No. Sorry. We have 410, and the sample size is for 700. And we are using this not equal to, and I prefer to draw. You can choose calculate. It's up to you. I want to see the graph. Make sure, wow! Make sure that in y equals you do not have anything else, because the graph will, the two graphs will superimpose. So make sure in y equals do not have other graphs. Okay, so we got that the test statistic is negative 0.2305, and look at the shaded area, which is the p-value, which is 0.8177. Huge. Okay. Okay, so round to 2 decimal places, negative 0.23. Determine the p-value. Gee whiz, amazing. It says round to 3 decimal places, 818. Okay, so let's stop for a second. This is the p-value, and alpha is 0.05. Compare and tell me what we do. Reject or fail to reject?
Fail to reject.
Of course. The null hypothesis. Failed to reject the null hypothesis. Awesome. So now let's see what, okay. So it's either B or D. So let's read. There is not sufficient evidence at this level of significance to conclude that the proportion of females who are living alone has changed. But let's read D. Do not reject. Fail to reject. There is sufficient evidence to conclude that the proportion of females who are living alone has changed. No, there is not sufficient evidence to conclude such a thing. Okay, how do we feel about this? Was anyone able to test if you can get in? Anyone who did the interactive, can anyone test? You let me know. Do we need anything else, or can we move on to the last section? I think there is a chat for me. Is there a chat for me? Can maybe I should stop sharing, so if it's secret. Okay, it wasn't secret. It was good news. Thank you very much. Thank you. Awesome. Sorry for the delay. If I had known last Thursday, I would have put my team on the case immediately. Okay, sorry about that. Okay, do you think we can continue? Okay, so we're going to repeat everything we just looked at. See why I like the graph? Because it also shades the p-value. Because it's a two-tailed test, of course, I have one piece here and one piece here. Half here, half here. Like alpha. Alpha will be half here, and the other half will be here, because it's a two-tailed test. Okay, so I'd like us to continue with 10.3. I saw that many of you already looked at 10.3. I'm very happy. The procedure is the same. It's just that we are using a different distribution. Okay, so let's start with 10.3. So 10.3, hypothesis. Let me write this for you so you know what we're doing again. So hypothesis testing for population mean. What we did in the previous section was about P, population proportion. So this was in section 10.2. Okay. So let's continue. I'm on page 3. All the same, let's do as many as we need. What am I doing? I lost you. Why did I lose my Zoom? Okay, I got 2 confirmations. Thank you very much for letting me know. Good. Okay, so we're back. Let me share my screen again. Here we are. Okay. So if you remember, we talked briefly about this distribution that is the t distribution. Okay, let me refresh your memory. The t distribution has something called degrees of freedom, right? So there are different shapes for different degrees of freedom. So T25 means that we are looking at a distribution that is T distribution with degrees of freedom 25. Degrees of freedom are always the sample size minus 1. So if the sample is 26, then degrees of freedom 25. And the shape is still bell-shaped, still symmetric around 0, but the standard deviation for the t distribution is not 1. For the standard normal, the distribution is 0, 1, mean standard deviation. But for t is not. Still bell-shaped, still the area, of course, underneath it is still 1, and so on and so forth. We are looking at probabilities or percentages, but the standard deviation will not be 1. It's different based on degrees of freedom. Okay, so now going back, in statistics, what does DF denote? So it's degrees of freedom. If a random sample of 25 speeds of cars on California Highway 405, so N is 25, so the degrees of freedom have to be 24, or degrees of freedom 24, definitely. DF denotes the distribution of freedom. No. DF denotes the number of degrees of freedom. And for this sample, if we have 25, N equals 25, degrees of freedom 24. It used to be to test the claim that the sample values are from a population with a mean greater than such and such. What is the specific value of degrees of freedom? Always the sample size minus 1. Okay. Which of the following is measured by the test statistic? Okay, so let's talk about that for a moment. When we talk about the test statistic, we already graphed it several times. So let's say this is a t distribution. And let's say I get here t statistic. They may call it t sub 0. Fine, it doesn't matter. Okay, so what does this represent? What does this number represent? It's the distance from the mean. Okay, so the mean is right here. The mean is 0. So that's what it represents. If it's here, if I get the test statistic to be here, then it will represent the distance away from the mean. And this comes from the sample. It's a calculation based on the sample, and it will give us the p-value immediately. So in this case, this will be the p-value. Here, this will be the p-value. Okay, so it's the distance between the mean. From the mean of the, and this is a number that comes from the sample. So it just tells us how far away from the mean this statistic is, or this, same thing. So let's read how far away the observed mean lies from the hypothesized value of the population mean. Correct. Okay, because it's hypothetical, right? So it is, we don't have it. We don't have the population mean. We wish we did, but we don't. So we want to test a hypothesis, right, for the population mean, but it's hypothesized, right? It's not known. How far away the observed mean lies from the true population mean? No. Right? So we don't have the population mean. It's hypothetical. Okay. And now the rest is conducting the test, but this time we're going to choose T test instead of a Z test. Okay, so a body mass index of more than 25 is considered unhealthful. I would say unhealthy, but okay. The technology output given is from 50 randomly and independently. This is the key here. They have to be independent, selected people from a health agency study. Fine. Test the hypothesis that the mean BMI, body mass index, is more than 25 using a significance level of 0.05. Assume that conditions are met of independence, normal distribution. Okay, so now this output gives us everything. Okay, so I'm going to copy it so I can explain. So in this particular example, we are given not n. This is incorrect. This is a lowercase n, not the uppercase n. Okay, the mean from the sample, x bar, 27.778. Standard deviation, S, 6.576. T, this is the T statistic, and it's not uppercase T. That's an error. So TST, 2.99, and that's not P. It's the p-value, which is 0.002. Okay, let me stop sharing. So again, sample size, sample mean, sample standard deviation, and the T statistic, and the p-value. So they're telling us what was the level of significance? 0.05, yes. Always copy the level of significance. Determine the null and the alternative hypothesis. So it says is more than 25. These are the key words, more than 25. So now the null hypothesis and the alternative hypothesis, more than 25 equals 25. So the alternative hypothesis always tells us the direction. So it's one-tailed test right here. This being alpha, 0.05. So now, test statistic. If the test statistic is anywhere here, fail to reject. If the test statistic is here, anywhere in the rejection area, reject the null hypothesis. Okay? Of course, what is the parameter that we are looking at? We are looking at mu. We're talking about not proportions, but population mean. Okay. So let's put the data in. I'd like to put the data in. Of course, this is very clearly, I don't need to show anything, but it's clearly in here. How do I know? Because look at the p-value. The p-value is this little piece here, 0.002. It's insignificant. It's so small. So it's definitely, p-value is definitely less than alpha, by far. So then I know that the test statistic falls in the rejection area. It does not fall here because the p-value is so small right here. So there is nothing to calculate. They are giving us everything at the beginning with this problem.